Very pleasant good afternoon to everyone on this side of the world, and good morning to the people who are on the other side of the world. So it's a pleasure having all of you here, wherein we are going to talk about doing engineering rather than reading engineering. So let me start my presentation so that I can just start. So very pleasant good afternoon, good evening, good morning, depending upon the place where you are. On behalf of National Institute of Technology, Karnataka, Surathkal, the place where I work is worship. And if you did not get a chance to visit NITK physically, please view our vtour.nitk.ac.in, which will give you a glimpse of NITK as it is. We are on the seashore, and we have been striving towards making sure that we are responsible and maintaining minimum carbon footprint, and we hope to reach a carbon neutral campus in the time to come. We have been ranked 10 in NIRF, that is National Institute Ranking Framework, and we have been trying to popularize EV within the campus, and which is designed, fabricated and tested by the students. With that, let us just look at what is that we like to talk today or discuss today on do engineering rather than read engineering. I'm sure that many of us are so familiar with engineering being read rather than done. So as Professor Subbu said, I'm Professor K.V. Gangadharan, presently chairing the Center for System Design, which is a transdisciplinary research center at NITK Surathkal. Let us look at how do we make students to get involved. Remember, I have two parts in this. One is before we become autonomous, that is when we were part of university system and transition. Then once we become autonomous, how did we look at things? So this is a case study of what we did and what we tried out. All that may not be quite relevant directly to some of you, but you should be able to modify some of these approaches and try your own experiment. That's why this presentation is done. So generally, they don't like to read, but they like to do. These are the learner's view. And the question is, most often people ask, just by doing, can we learn? Whether the learning happens through doing alone. And can we enrich through further reading when things do not work? So this is something which I have been working. Learn why when you fail. So if system thinks what you designed or created, or it could be an algorithm, it could be a physical model, or it could be a mathematical model, when it fails, learn why it failed. Of course, this is not the general approach. First learn all the alphabets, then put the words, then the sentences, then start speaking is our normal approach. Now, start speaking. When things go wrong, come back to the basics. This is what I'm trying out. And I have a reason why I tried out in this way. During 2001 and 2004, that period was, NITK was transitioning from a university system to an autonomous system. We were under Mangalore University until then. Then it became Institute of National Importance and NIT and all that in 2002. So even then we were just slowly changing. The autonomy was just gotten and we were changing very slowly. So during that period, I came in as after my PhD, 2001, and what all things we tried out in order to make our students get involved is that what I'm going to present. And after that, how did we move forward, making sure that the freedom available in autonomy is being used quite extensively in the classroom. Okay. So first step we tried out in 2001-2 was making students grow. One difficulty we had was no funding was provided for any such things. We took it as an opportunity rather than a constraint. Any constraint given to you as a teacher is going to be an opportunity because you can find an innovative way to solve that. So let us have different constraints. Still, we work towards overcoming the constraint in an effective way by innovating methods. So first thing was I wanted all the branch students to work together. And remember, I cannot do much in my syllabus because the syllabus is decided by the university and we have a very structured approach to complete that during that non-autonomy period. So hence we formed groups of students and made them to do it yourself competition within the institute first. And that picked up. In 2003, we made it as an event for other institutions. And we named it as TechSplash 03 and TechSplash 05. That time I happened to be an ISTE chapter secretary or the faculty advisor or something of that kind. That gave me a group of students who are from different branches of engineering and who are also from different years of engineering. I could make use of them and have a program conducted for different problem statement given by the student group and different groups of students from other institutions trying it out. That was called TechSplash as a technical event. And by 2 editions of that, we found it is growing much faster than we expected. And we made it as an institute event, converted as an institute event, which now we call it as engineer. And the official logo is that Penrose triangle serves as a statement to challenge the impossible. And it is also accompanied with a motto, think, create, and engineer. Here, engineer is a verb. Remember, all these are done through the students and by the students. Our involvement in creating any of these statements were minimal. It was more to do with just an approval kind of a thing rather than getting involved. So by this, we could make student group actively doing things, starting from simple management activity to organizing logistics and doing actual engineering work. These created a momentum in making students to work on all the out of classroom projects. So here, why out of classroom projects? Because our freedom on doing classroom projects were restricted because of the university system. So those who are from a university system still have an opportunity, saying that even though your syllabus is set by someone, your subject is taken by someone else. That is, there are 4 variables. That is, syllabus is set by someone, the classes are handled by some other group, question paper is set by a 3rd group, and the evaluation is done by a 4th group. So whereas in an autonomous system, it is the same double does all that 4 activity. And that difference, I'll show you how we made good use of it afterwards. So now this is one of the India's most awaited technical festival now in 2K22. It was just over. More than 150 engineering institutions participated all over India. So this has created good amount of enthusiasm, and it is continuing for last 20 odd years now. Then in 2007, SAE Baja, it is pronounced as Baja, but it is written as Baja, BAJA, and Formula SAE came. 2007, Baja came to India. Until that, it was only for international event. And first time in Pidambur, near Indore, the NATRIP facility was used for testing this. First time when we announced our students are going to make a vehicle, and that is going to be run in a treacherous 27-kilometer treacherous all-terrain running in a test track. People were laughing at us. And we could convert that laughter into energy and convert that as a product. That gave us a lot of confidence. If your idea is not laughable, please don't attempt it. And likewise, when we said our students will make a vehicle, all-terrain vehicle, and run it. And it looks very not that great nowadays, because now every group of students are able to do. But in 2007, when we said, it was something quite new. And after that, 2010, we got the same kind of group to compete in a Formula SAE competition. That's again, it was international. By the time we had gained popularity and got sufficient funding from sponsors to go for an international event. So here, first experiment with out of classroom project could deliver more amount of such similar projects and make different batches of students, that is different years of students in engineering, different branches of students in engineering work together. And then we saw there is a lot of interest in robotics. We found that there was a Robocon competition, which Doordarshan and few other organizations put together had conducted. And first edition onwards, we started participating. So it gave us students to work in deep technology. Quite few people who are doing system design, sub-assembly, electronics, embedded system, and all that came together along with mechanical, electrical, and other group. So this gave a lot of importance for doing engineering as such. All these were out of classroom activity. But by 2007, 2008, we had stabilized in an autonomous institute wherein we had the freedom to specify what kind of evaluation we are going to do for the course. And that gave us, me and many of my colleagues together started working on giving each module of a subject having a small part of a mini project to do. First, we started with something to do with software, simulation. Then we started making them to do hardware. Again, one condition was minimal expenditure because there was no institutional support for this project. Hence, we wanted students not to spend much. So what you see on the screen is to do with all minimalistic approach of creating some mechanisms. And behind this mechanism, a lot of calculations happens, simulation happens. Finally, they build it and show how this works. And it gave them very good exposure. This was done in third semester. Third semester, it gave a lot of exposure on doing things and how what can go wrong when you are doing and how that can be used in mathematically modeling it and understand what really went wrong. And that gave them each subject more an experiential way of learning rather than remembering the concept. Especially the items which you see here are all taken from standard activities in an mechanics of machines third semester mechanical engineering subject, which can be mapped onto any other subject. Suppose you are doing electronics or electrical engineering, it can be analog electronics or digital electronics or embedded system or signals and systems, all that we should be able to do something similar of making every module, creating an experiential module in the class. The first time we had difficulty because we had to find an extra time for this. Many of us volunteered to work on a Saturday and students also shown interest, and half day in every alternate Saturday we were devoting for these classroom projects. And believe me, the interest was without any compulsion, everybody was getting involved. And that is something which you feel so happy as a teacher when somebody is getting involved themselves and on a Saturday morning they willingly come and participate, because we saw much higher enthusiasm in these project classes because we have divided them into 5-member groups and randomly picked members. That was another experiment which we did. We did not allow the students to group themselves. We said you have no choice because your boss cannot be chosen, your colleague cannot be chosen in your job, or rather you could not have a choice of your mother or a father or geographical location or caste, creed you born. Hence, we said we will randomly pick 5 members and make a group. And initially there was a resistance, but finally they understood they can work with any group given to them. And they created many of this. This was an experiment we did when we had the ability to modify our classroom approaches, which I am not sure whether everyone will be able to do when they have a university system. But still within university system, I am sure that there are many things which can be done. Now, these are classroom approaches which we did. Now let us look at the term experiential learning. So here we coined that approach called doing engineering or science rather than reading engineering or science. Now, this is our students sitting for a BTech in swimming engineering. And the teachers gives a dry run of this kind. And at the end of 4th year, when we give a BTech in swimming engineering, I'm just making a statement that way, they won't be able to swim. And this is what is happening in general, because most of the subjects which we teach are conceptual and textbook oriented without making them practice what they do. Or the concepts are most often remembered, rather than experienced. So we want both teachers and students to get in and start doing. So let us make them do together along with the teacher. And how do we do that? Remember the constraint. There is absolutely no funding coming from your organization. You need to manage it without funding. So that is the bottom line which I am making. So let us look at evolution of guru. I'm sure that this guru is still in the textbook or in a picture, but presently we have gurus all around like this, and our dhyana goes like this. And what our smart students are looking at are the loves and likes which they get for the social media. Can we convert this itself as an opportunity? So that is what we were looking at. Can I make experiential learning online so that my smart students who are all the time online can sometimes get into this experiential learning module and get benefited out of it? Whenever we think about experiential learning, this comes to our mind. That is something to be done by hand. And be ready for this if you are doing like this. Otherwise, if you want to avoid this, and it's not a perfect method, but it can be a scalable method for providing experiential learning if you are able to use computer as a via media. Instead of doing by hand, if I can do things with computer, creating an experience of an equation, experience of a variable change, experience of some property variation, etc. So I'm talking very specifically to some subjects now, but this experience can be created through computer modules. Now, let us specify what we need. I would like each one of you to dream. You could be an administrator or a professor or a faculty or a smart student. Now, all of us are going to dream about the teaching and learning. I know we have much better things to dream about, but let us dream about teaching and learning. And let us specify our dream. We engineers are so good in specifying to give specification for everything what we have. So let us look at a lab and a learning management system, which is a lab and a learning management system, which is at my place, the learner's place, at learner's pace, and at learner's period. So assume that as a student, I want to do an experiment at midnight, 12 o'clock. Don't ask me what experiment. I want to do an experiment at midnight, 12 o'clock. Is there a possibility? And I'm a quick learner. Instead of making me do one experiment in a week and wait for the next experiment in the next week, can I do all the 10 experiments together and one after the other because I am still able to absorb? Or I am a slow learner. I want one experiment to be done 10 times because I want to get it right. And I want to do it at my place. So this is a dream specification, remember, a lab and an LMS at my place, my pace, and my period. So, and I want a lab which I can take home or carry with me wherever I am. And I also want the lab which to be with no holidays and no lock and key. And obviously for an Indian situation, it also have to be mapped onto the syllabus of different universities. That means the lab should be working for me, for my syllabus. And at the end, we as a learner, we are also looking at getting the dream job. So, and I should be also able to change the job. Now that is another criteria which we have started looking at. Maybe an IT job to a core job or a core job to a management job or vice versa, or altogether a new area, depending upon the latest trend. So these are the dream specifications we have given now, and we need a lab to be created. So Ministry of Education came forward with a concept of virtual lab, which 11 institutions were asked to be together. I just look at my screen. I think it is frozen. I hope it is coming through now. So
Video is not coming through, but the screen is coming.
oh, okay. I think it is taking some time to come through the video, I think. Okay, that's not an issue. We'll just look at the part screen as such. So the virtual lab, the Ministry of Education under National Mission for Education through ICT, with 11 institutions as participating institutes, and IIT Delhi as the lead institute, created this. And that is the specification which we have given now. What this virtual lab is all about? It is available at vlab.co.in. And to give a specific thing, any concept can be either simulated based on the equations or the method, and it is a simulation or modeling based lab. Or if you want some experiment to be conducted, n number of experiments can be conducted. The data can be used, and the same data can be given when an experiment has to be done from the computer-based experiment, that is virtual lab. Or we can give the actual experimental setup under remote control. In fact, this is what I started with. We wanted some of the equipment to be used in the night from the hostel. My initial activity was limited to hostel. Intranet, I wanted some of my equipment to be given to be used in the night. So that's where I started with the remote triggered experiment. And then in order to make it happen, we started making simulations because we wanted to create how to use the equipment first. Hence, a simulation was made. And that way, we also wanted to create something to do with experiments where data are collected and shared. So these experiments, when we got the opportunity to work with Ministry of Education's virtual lab program under ICT, NME ICT program, we made similar labs for many of the subjects. If you look at these labs, when you look at the reality, remote triggered lab is close to the reality. But for a nation like India, where scalability is much more important, it is not scalable because you need to make all the equipments made available to the rest of the world or rest of India, and you need a lot of investment. Whereas the simulation-based lab or measurement-based lab is much more scalable. So we started focusing more on modeling and simulation-based lab. Remember, our approach is to create experiential learning of every subject which the learner learns. So instead of remembering the subject, we want them to experience the subject. So that was available through vlab.co.in, and we also have rtlabs.nitk.ac.in. So I'll just take you through one simple example. Maybe I'll first take you through the on an simulation and the PPT itself, then I will show the demonstration quickly. So if this system has to be explained, for me, it is a set of input and the input getting modified through a mechanism, and that gives you the end result. The input for me is the pedaling, and it is getting converted to a rotation. That rotation is getting converted to reciprocation of the needle. And when the needle is reciprocating, the thread is getting entangled. You can see how one thread is moving out of plane and getting connected or knotted by the next thread. So this can be explained as a mechanism and how this required modification of the motion can be achieved. So another simple example which we can show is the wiper. Remember, I am focusing on one subject to give you the concept. Then you can map it to any one of the subject which you are taking or you are using as such. So the wiper, if I want to be looked at, I can look at like this, a rotation getting converted to a reciprocation or an oscillation. And I can subdivide this movement to basic mechanisms. Maybe a slider crank mechanism, which is very similar to an IC engine mechanism, or an IC reciprocating compressor mechanism, and or a 4-bar mechanism, etc. And if I want to get into robotics, I can still look at the same basic concept. Now, irrespective of the subject which I am using, when I am talking about kinematics or mechanics of machine, I'm using the same basic building block, making students making the students to experience that basic building block. It could be a landing gear, or the way in which the landing gear can be folded and four-bar mechanism, etc. So, or if I am looking at a reciprocating engine or a compressor, both have the same mechanism. You can see the piston and crank and the piston, how it moves. So essentially all this I am bringing down to the basic mechanism called slider crank mechanism. Then simulate conditions on that. So from here, I will do one thing. I will show you I'll stop presenting this and show you the website directly. Let me present the screen. I'm just getting the is the screen is shared? I'm not able to view from here.
Yes, it is shared.
Okay. Yeah, thank you. So
Somehow it went back to your.
yeah, now I hope I'm getting back the same screen, no? The virtual lab screen.
Yes.
Okay. So this is a website which you need to go and okay. This is a website where Ministry of Education's national mission. You can either choose from the broad area of branches. As I know what labs which I'm looking at from my institute, I have kept it open. So I'll just show you which are the labs which NITK Surathkal has made. And these labs are of different kind. And I'll just show you what I have just demonstrated now using that PPT. So these are the mechanics of machines labs, wherein each lab will have an activity like this: aim, theory, procedure, and self-evaluation. This self-evaluation is a student doing a self-evaluation in the beginning in such a way that he or she knows what is the level of his understanding on the subject. So that's why there is a pre-test self-evaluation. After the pre-test, we also have a post-quiz. That gives the student to know what is the delta X he could get when he did this virtual lab. So that's why we have created two tests there. One is before doing the experiment, and after simulated experiment and doing assignment, then again one more quiz. So here the parameter can be varied, and the student will be able to find out what happens when a parameter is changed at every distance. Maybe this position analysis may not be looking that complex. We had made everything together in the initial case. When we went to different institutions, we found that it is difficult for many of the students to understand when we have a single experiment. Then we created multiple experiments. Position analysis as one, velocity analysis. This gives the velocity analysis. I can change the parameter. Now those who are from different field can map it to their subject. An equation is available. Each parameter can be varied. I can also stop this. For a given angle, I can find out what is going to be the velocity. So if I want to see at 90 degree, what will be the velocity of the piston? What will be the velocity of the slider or the crank? All that can be identified. This here bottom side, we also gives the actual value. Okay, so here you will have this value printed. Now from here, even this is not that complex. Go to the next level, wherein these are three different experiments: position analysis, velocity analysis, and acceleration analysis. So we get into here. So again, all the parameter can be changed. From there, I can go further and see whether I can do a dynamic analysis. So what I'm doing is I'm just finding out the acceleration. Then I can find what is the dynamic force. Again, further, I can shift it to acceleration and see whether I can create different mechanisms and experiments. So wherein one should be able to look at different controls and change the control and find out whether the experiments can be done. Different experiments can be done. So this is one. And it can also go further to many other subjects. So I'll just show you one example of a 2 degree of freedom system. So you can change the parameter and see what happens in this system. So it is not that normal to see such things, and this can be used in the classroom. So the experiential learning taken along with a student, and the teacher is covering the topic. And the advantage here is it can be viewed by the student then and there on their mobile. So I encourage students to use the mobile in the class, and we saw that they are not misusing it. They were able to get involved more and ask the right kind of questions when they get involved, and they simulate and see whether the conditions are satisfying. Because the kind of questions we got when we involved them in the class was much better compared to ask them to do sometimes later and come back. So these experiments we tried out. And along with this, we also have, let me just move on to this. After that, we also have experiments on vibration. So I will avoid vibration now, and I'll just get into one remote triggered lab experiment. So what you see now is a remote triggered experiment. Let me just see whether I can trigger one of the experiment. This is an RT lab in vibration. I'm opening the lab. This is the experiment. I have connected. I am now triggering now. So you can see on the screen. I'm just enlarging the screen. You can see this is a live video feed coming from the lab. I have just triggered and it started moving. It's a pendulum experiment. Some of the simple experiments which I am showing, and it gave me the data. Now I can go here, find out what is the amplitude, what is the time, here the amplitude, here again, and I can find the logarithmic decrement. So those who are from electronics and electrical background, this same as your RLC circuit or an RF antenna, because it is the same second order differential equation which we are solving. Or those who are from heat transfer, again, similar kind of equations. So this can be mapped onto any equation, any experiment that you have in mind, and which can be made remote triggerable. So this is one experiment. Now I would like to change the parameter. This is an actual experiment at NITK. I'm now changing the length of the pendulum, and let us see whether when it is changing, I'm just enlarging the screen. I'll keep the cursor on that green dot. Once it is activated, and I'm doing it from, now presently I'm sitting at home and the experiment is at my lab. You can see the length is increasing, and all these items are made by students and using hobby electronics. We did not go for any high-end activity. Remember the statement I said, we have a lot of constraints on funding. With available funding, is it possible to create experiential learning is the question. Now the length is changed. Let us just give one more trigger. So I'm going to trigger with the new length now. Believe me, there is no login, there is no authentication required. Anyone and everyone from anywhere in the world will be able to make use of these experiments. So this is the second experiment. You can see a slight delay in the video feed, compared to the data coming in. So now I have data 1 and data 2. I can download this data and do the further experiment, further calculations. Here it allows you to do the calculation. I'm proceeding to the calculation. And here, what are the observed frequency, theoretical frequency, etc. And once you submit this, it will also give me what is the value which it has calculated and what is the error which I have. Of course, I did not enter any value, hence I have 100% error. So this way, the experiments can be used to make sure that we are able to provide an experiential learning to the students. So let me just conclude by saying, whether you are a university system or an autonomous system, there is a possibility to introduce experiential learning module in your classroom, even if you are in a normal university system. That is one. Second, it doesn't require too much of a money support or financial support from administration. That means as a faculty, I have the freedom to implement such things in the class. And we could get, using these kind of things, we could get into much more complex activity wherein we developed many of these, what you see as the Vidyut series of e-vehicles, because these things gives the students the hope that, yes, they are able to get more and more ideas and implement it. All these were done through the students and with not much of a, the activity on money part. So let me conclude by saying, any faculty who is interested to provide experiential learning, there is always a way in which it can be done. Every faculty, even without an financial support, within the limit of your own syllabus, will be able to implement experiential learning. Presently, many of the subjects are available as an experiential learning module from virtual lab that can be tried out. And you can also make students to do such things. So that can give you much happier, smiling face. As a teacher, you will be happier when you see more people smile at you in the class rather than they curse at you in the class. So with that, let me thank the Craig group to organizing this, and I'm awaiting the questions and discussions.
Thank you very much, Ganga. Unfortunately, we still cannot see your video. Yeah. And we have about 15 to 20 minutes for questions and answers. Who would like to go first? And I can unmute you. If you raise your hand, that's one way of asking the question, or you can put it in the chat, whichever you prefer. Before anybody jumps in, maybe I should say a few things. I think what you presented was really fantastic. It's very inspiring. And also the idea that we can even provide experiential learning, even a 2D flat screen, by animating things and giving them a sense of the real in the simulated world is very, I think, interesting and revealing. And I have a question. In a way, what you're doing is really creating morphological charts of mechanisms, right, underneath, so that they can learn those morphological charts and use them appropriately in the context in which that particular function can be achieved. So there is a notion of generality, at the same time specificity, that is being taught to them in this process. Am I correct in that?
Exactly. I did not go technical because it was a general group.
Yeah. No, I just wanted to clarify both the pedagogical and the imaginary part of the student that is being provoked in this process, right? So they can see an actual mechanism and imagine it in their mind through these simulations as some kind of mirror neurons for them, right?
Exactly.
Okay.
There's a question in the chat asking about the video. So I just wanted to mention that video of Professor Gangadharan's talk and the previous 3 talks in this series Those three previous talks are already available on CREE website. I have sent a message in the chat, the CREE website where you register for these talks. And Professor Gangadharan's talk video also will be posted there.
Yeah,
So
it won't be probably till mid next week because of time. And yeah.
But please feel free to share the link with your friends who might be interested.
Yeah, what I'm saying is the opportunity to digitize lot of knowledge base, like for example, different kinds of mechanisms and all that, and then create a possibility for experimentation by students. Where they can vary the link size, they can explore whether one mechanism, effectiveness of one mechanism versus the other. I think this opens up space for a lot of experimentation on the existing knowledge base. That is one strong value. Second is the remote experimentation. What is the scope of the instruments or the applications that you have explored as of now? Is there some possibility for extending this to a little more complex machinery?
Yes, we did it with, we have done a PhD experiment on control system. The person was sitting in Agartala. One lady came to institute only for 40 days, 45 days. And the control system and their experimentation parameter variation was done using remote trigger. And we also did some experiment using piezoelectric crystals and piezo patches on MIMO systems. It is possible to do for a variety of things. And as the complexity increases, the type of handling, that exception handling become complex. So what we
Professor Gangadharan, can you turn your video on, please?
Shall I just get out and come back, log out and log in? Umar,
turn your video on so people
can... it's not on, but for somebody, yes.
Give me one moment. I'll just come back.
Also, Umang, there's a question from Dr. Venugopal asking the feedback loop, a feedback link. Is there a feedback link on our website for the videos?
We don't have any. I could create one now, and I could maybe create for every session we have.
I think that may be nice because that's what Dr. Venugopal is asking for.
Cool. So just give me 2 minutes. I will
have not right now. We can inform him later on, but this can be done later. Okay.
Sure. But we'll have it from next sessions for sure.
Yes.
While Professor Gangadharan is getting online, meanwhile, I would like to mention to the people who are attending, if any of you are doing experiments of this kind in your institution, we would be very happy to hear about it. Please do contact us. And that could be another avenue for exchange of information. Yes, Shyam.
Not just in the universities, but especially in the industry, at the workplace. If any of you wish to give a talk, please contact us.
And Professor Shyam, is it possible to share one of your email IDs where maybe people could connect up and share things? Would that be suggested?
We should give a common email ID on CREE. I think that will be much easier.
Okay, I will post it on CREE, and so we can have solicitation of people who wish to propose.
You can give my name too, it's not a problem. Right. Eventually we have to go to a CREE mail system. Yeah. You are still not coming through, Professor Gangadharan. I don't know.
No, I saw the video is not coming through. I'm extremely sorry about it. I'm on video, but it's not getting. I have closed all my other programs, thinking that it is consuming a lot of bandwidth. Still, it is not coming. I'm sorry. Vijay Raman has raised the hand. Please go ahead.
Please go ahead. Please.
Yes, Professor Gangadharan. I just wanted to know if you had any plans to do slightly more complex experiments with the young people you are teaching. For example, if you are looking at things like how to get hydrogen to be used in more greener spaces and so on, because that would be really something very innovative coming out of an institution like Surathkal.
Yes, we have been looking at possibility of creating complex experiments. We saw that the end users numbers are limited. Present focus was how do we satisfy the mass. That was the ministry's requirement. Hence, the focus was on basic subjects. Now, on the sidelines, we also started creating more and more complex experimental setup, including combustion and things of that kind, wherein we also started looking at the energy sources, hydrogen related activity, and different kind of battery and battery systems, etc. Of course, it has not yet come to a level where we can put it online, because all these items which is put online had a different review process. So we are still awaiting some of the things getting reviewed. Once it comes, obviously it will be available on the VLab portal. And not only NITK, all other 10 institutes along with NITK are also preparing. You can see 7 of IITs are there: Amrita, IIIT Hyderabad, COEP Pune, Dayal Bagh, and all the institutions are available. All of them are creating experiments. Present mandate given to us from the ministry is to finish the subjects which are basics. So that's why most of the things which we saw there are some of the basic concepts. But we also have started working on cutting edge technology and deep tech areas where experiment can be simulated.
Actually, I'm going to ask a question if nobody wants to ask one. As you get to more complex machinery, it might be difficult to actually do remote experiments. I was wondering, given that they are doing this virtually and they don't have access to direct labs, they may even go to a local carpenter or electronic shop and try to produce these things themselves, carpenter, machinist, around the block, so to say, and see whether they can produce them themselves in their neighborhood. Don't you think that could be another way of getting them engaged with the neighborhood industry, as well as skills that are available to produce these prototypes? This is just a wild thought, and I would like your reaction.
Yeah, in fact, we saw students who didn't want to spend time on this in just creating this. Those who found happy in making the simulation and understood the things is really went into an outsource mode and went to the carpenter, asked them to make. But even then, they saw that they have to spend time because it has to be explained, the dimension has to be given, things of that kind. But that also we saw. There are complex mechanisms, especially walking mechanisms, etc., made by carpenters, but students sat with them to make sure that things are happening in the way it is required. That is something which is we saw people are doing.
What I was looking at was spillover effects, right? They are spilling out over the simulation game into the practical regime. Yeah.
In fact, we saw that happening.
Professor Gangadharan, if I may ask, what is the software being used to connect the laboratory equipment to the visualization at diverse locations?
So here presently what we did is all the equipments which we have are connected through LabVIEW, and there is one machine running on real-time operating system, which is RTOS, real-time operating system, and that is the lab machine or a plant machine, you can say. Then I have an external machine which is running on Linux, which will interface between these two. And the third is our server, which is coming from the central computer center. So I have 3 layers of protection so that an external intruder cannot come and disturb the system. So this is one part. And second part is wherever possible, the outside looking activity are done on an open source, HTML and Java. Nothing more than that. just HTML and Java. Hence, any computing device with a net connectivity should be able to do this. And such things have been taken care, and we also made it lightweight. So what is just required is being transmitted, and the same way what a user can give input is also restricted, so that the traffic between the server and the client is limited. And what is the only place where we saw slight delay coming in was the video. So that is we are still working on how do we make it as realistic or as real time as possible.
So to develop the system, you need somebody who can do Java and HTML programming.
Yes.
Is that right?
Yeah, that's right.
Have you considered the possibility if the data from the mechanical or engineering system is fed into something like an Excel worksheet? An Excel worksheet can easily be programmed by the individual students to give them the visualization of the data coming from the machine or the engineering lab.
Yes, that was our initial stages where students did not find it very exciting. That's what we saw. So we then moved on to
Shyam's question, I think.
I mentioned Excel only because a very large number of students will have, might have, I would have imagined, Excel programming skills, but may not have the ability to program in Java or HTML.
But in Indian students, what we saw is when I give an opportunity to do coding, students were showing more interest. I don't know whether it is very specific to an Indian condition. And even the student who did not like coding and came to mechanical engineering, because I am from mechanical, and of late have been showing a lot of interest in coding and learning coding. And in fact, if it is related to a subject and it is a part of the evaluation process, I saw much more interest. Because whatever experiment I did with out of classroom, now it is not picking up that well. Whereas when it is a classroom activity, I am getting much better response. Because there is a reward attached to it.
Yeah. So one question, which is, LabVIEW is a commercial software which you can buy, get academic license. But the rest of the software and other things in terms of server and other things which you have built, would it be useful to make it open source and allow other institutions to participate in actually building not only the underlying infrastructure, but also the underlying knowledge base, but also the infrastructure? And could that form a basis of some of the things, Cree could promote in some portion?
In fact, exactly.
May I just modify that slightly, Sub, if I will?
Sure.
That by open source, you mean not only NITK making what they have done open source, but possibility of creating a platform at which NITK and other institutions and individuals can make contributions. So the lab content will grow in terms of the experiments which can be carried out. I suppose that's what you meant by open source.
That's what I meant, but I also meant the underlying infrastructural software itself to be available for others to enhance and so on. Interaction between the server, the Linux system, and all of these different pieces which they have figured out that could form a basis for expansion into more people or more experiments with remote systems. So all of those kind of things. I meant both. Both the content and the computational infrastructure.
It is being done. We have now 450 colleges connected with NITK. We call them as nodal centers of virtual lab. And some of them have shown a lot of interest. In fact, there are institutions who picked up from this and made a startup out of it. And they have running labs as a service.
Mm.
In fact, all that activity what we are doing under NMEICT are available for non-commercial applications. So you can download the code, you can modify the code and use it for any non-commercial activity. So it is already available as a general license, NCC it's called. CCC, I think.
Yeah, Creative Commons, yeah.
Creative Commons license.
And you also have them to, do you have a repository in which their experiments can become available in a centralized sense?
Yes, we have a GitLab.
Okay.
Anyone can take the item out and modify it and run it themselves, because these are, as Sudhir just mentioned, these are information already available. We made it in a specific format so that it become an experiential learning module.
Thank you so much. We are just about an hour. If there are no questions from anybody else, I hope you enjoyed the talk, and I think it is quite a interesting direction to take in terms of mass education and learning by doing. So with that, I think, Ganga, thank you very, very much for doing this. And let's hope more people will join our group. And
next talk.
Yeah, and the next talk is on April 19th by Professor Sujata Srinivasan. And I will be putting up the abstract and other things. Umang and I will make sure that the announcement is out, and we will also send you a reminder the day before the lecture. Anything else, Shyam, which I left out? Is that okay?
I think we've please ask your friends and others who might be interested, faculty and students, to join in for future lectures and visit our website to review the videos of past lectures. Thank you.
Thank you.
Thank you. Bye-bye.